Hello all. In this session I am going to discuss about CNC program, which is in line with my previous lecture where I have explained you about two types of coding system. One is preparatory functions and one more is miscellaneous functions, and these preparatory functions are denoted with G whereas miscellaneous with M. Now by making use of those simple codes which I have explained you, let us try to learn a simple program. Okay, to write any program you need to have the question with us, so I just try to draw a simple profile so that we can write the program based on the profile. Okay, fine, let me draw a simple sketch. There is a plate of this kind, a rectangular plate with let us take some chamfer. All right, a plate is there with some dimension. Let me give some dimensions also. Let us say this is 0 comma 0, and let us give some plate thickness with some other color. This I would say from here to this point it is 80 millimeters, and this distance is again 80, and this point, at this point it is, if I'll say this is 10 by 10, let me see later. Now it is 80 by 80, so this distance, let me call this as 10 mm. Overall it is 90. Okay, so here it is R5. Okay, accordingly we need to write a program. Now before writing any CNC program, one should understand the problem first. Okay, followed by the coordinates. We need to mark the coordinate, that is more important. For example, if this is 0 comma 0, this is the origin where exactly the tool will start its movement. Alright, now what is the vertex? What is the coordinate at this point? At this point, what is the coordinate means? It is 90 comma 0. Sorry, 80 comma 0. 80. The distance is 80, no? 80 comma 0. At this point, it is going to be, I am calculating each and every vertex point with respect to the origin. Then the command we use is G90, which is absolute way of calculating. Okay, if that is the case, this particular point is 80 comma 80, 80 comma 80. All right, similarly this point, now this is mentioned as 10, so obviously this will also maintain 10 by 10 equidistance. So this vertex point is going to be how much? That we need to calculate. The calculation again with respect to the origin. So if that is the case, this is 10 mm, overall 80, 80 minus 10 is 70, x is 70 comma, overall height is 90. Overall height is 90. That is also correct. Now this vertex point you need to calculate, tangential point, sorry, tangential point. At this point with respect to origin, what is x, what is y? X is 5 already, r5 is given, and y is 90. And at this tangential point, what is x, what is y? X will definitely be 0, followed by y is how much? 90 minus 5 will give you 85. Okay, so initially we need to mark the coordinates first. Once you get all the vertex point coordinate, it becomes easy for you to write a program. Now let us imagine that there is a tool compensated here, which is right when I observe from this side. Okay, that I'll write it in a program, like how to write a compensation command and all. Okay, now when the tool travel from the first point origin till the next point, it is traveling linearly, the command is going to be G01. Okay, now the tool will remain here. Now from here to this point, again the command is G01. From here to this point, command is G01. Again it is linear, G01. At this point it is a counterclockwise rotation, which is, the command is what, G03. Okay, again till the origin it is G01 only. So we know all the commands. Okay, coordinates we have already marked, then all the commands we have written. Now let us say if the movement of the tool is in a clockwise direction, obviously here the command is going to be G02, which is a clockwise rotation, but our case we are going in a counterclockwise rotation. It is your wish whether you want to go clockwise or counterclockwise, but accordingly the command has to be given. That is more important. Now the way I have decided, initially whenever you start writing a program, you have to decide one thing, whether you are following absolute system or incremental system. That is first point. And again, the question given is in millimeters, metric information is required, or inch information is required. Based on that, you have to change the code. That is more important. Alright, speed and feed will obviously be given in the question, so no need to worry about that. Now let us start a simple skeleton of writing a program of this kind. Now let us say if this is the origin, let me draw a simple coordinate system here. This is okay, coordinate, first quadrant, second, similarly the third one, then the, alright, if there are four coordinate system, we know from the basics that this is going to be positive first quadrant, because this is x, this is y. Alright, then this is negative, this is negative. The coordinate, now I have considered this point as origin, this point as origin, and I'm moving around something like this. So this part or the workpiece belongs to first quadrant, so all are becoming positive both x and y. So based on that, I just try to go with some writing a simple program. But before that, let me give some input data required. Let us take, for your understanding, cutter diameter as 20 mm. That is first requirement. One more requirement is speed is equal to 1000. For our case, anything is fine, but just for your understanding sake, f is equal to feed rate is equal to 200, and that's it. What else is required? We should know the thickness or depth of cut is more important. In some cases, depth of cut is given to you, or else if it is an end milling operation, based on the thickness of the plate. For example, let me draw a side view also. This is the side view. Okay, let me draw again. This is the side view. Alright, let us imagine. Now the thickness of the side view or the plate is 3 mm or 5 mm or etc. or anything. So based upon the thickness, accordingly we will consider that as the end milling thickness or depth of cut. Okay, in few cases depth of cut will be given to you. Depth of cut is equal to some 5 mm. If that is the case, the depth is taken in z direction. Alright, Now let us start writing a simple program now for this case, for the plate. Any block is represented with n alphabet followed by the number. It could be n001 or n01. It all depends on the length of the program. If the length of the program is in hundreds of blocks, then n001 is always preferable. If it is in different, the rows what you are going to get are in thousands, definitely this I can take it in 001 or 0001. Okay, this n represent a single block. Single block will contain multiple codes. Okay, so initially I can write it as G71, which is a metric system, followed by a space, G90 absolute command, and G94 is for feed rate 200 millimeter per minute. Alright, then second block I'll start with N02 followed by G00. I would say, let us imagine I have placed this tool somewhere near the origin, but let us imagine that the tool uh, tool initially is at some offset distance. Okay, what is the distance? Let us consider the distance also. This is the distance. Let us take 20 by 20. Okay, 20 in x, 20 in y direction. Now as I said, the plate belongs to first quadrant. When it belongs to first quadrant, whatever the position of the tool is there, that belongs to third quadrant. If it is in the third quadrant, both are negative, x and y are negative. Alright, if that is the case, let us say, for our understanding purpose, I just try to give some number just for understanding, G00. Let us say the tool is positioned at -20 and +20, -20 +20, somewhere here, -20 +20, somewhere here, that need to be taken to the origin. So for that case, what I do, G00 followed by x. So to reach the origin, it need to travel 20 mm in x and 20 mm in y, followed by the third one, N03 G00 Z10. Okay, G00 Z10 means the tool will reach the origin, but it will not be in contact, or it will not stay near the workpiece. It is 10 mm away from the workpiece, you can say, or else it is not crossed the thickness. It has not went up to the depth. It is almost at the tip of this particular thickness. Imagine that way. If that is the case, next I can say N4 followed by 01, linear interpolation. The tool has to travel all the way. Then G, before that it need to be compensated. Then Z value should be given negative. Then whatever the speed given, write it down. Feed given. Okay, then followed by start the spindle. Okay, then the next blocks, fifth block, nothing but G01 X0 Y0. There won't be any full stop or comma between the numerical and the alphabet X. N06 followed by G01 X and Y. X90, Y will be 0, this position, sorry, X80, Y0. So the tool till here it will travel. Okay, it will travel till that point, N06. Now the next one, N07, N07, from here to the next point, G01 again. Command already I have written on the plate or the profile itself. X80 and Y80. Okay, X80, Y80. Now N08, and now it is all about a preparatory function. 01 X80, no, not 80. Let me go back, because it has to travel from here to this point. This point, what is this point? 70, 90. X70, Y90. Obviously it will go to that point. N09, G01 again. What is X and what is Y at this point? 590. X is 5, Y is again 90 mm. Alright, now the tool is at this point. From here to this point it is going to be 0, N10, G03 this time, because it is moving in counterclockwise direction. 03 is the command preparatory, followed by what is X value, what is Y value. X is equal to, already written here, 0, there won't be X movement, and Y will be 85. This is how the 10th code is going to be. Okay, so when it is a 02 or 03 command, you are supposed to give the radius also. R5 you are supposed to mention. Other than this radius, ith term, jth term will also comes into picture in some few of the machines that we discuss in the upcoming lectures. Alright, again one more thing, next block N11, where G01 again. Now from here the tool should reach the origin again, X0, Y0. It reaches the origin. That is okay, but after reaching the origin, what we supposed to do? G40 is required, where the code has to be compensated. G40 compensation should be cancelled. Then N13. It is not compulsory to use G40 all the time. It is not going to make any difference if you stop the program directly. G00 followed by X minus 20, Y0. So I'm taking away that particular 2. Then again 14, G00, Z direction. I'm taking it up to 20 mm or 25 mm. Then finally N15, you are supposed to stop the program. Alright, I hope you understand a simple program how to write for a given profile. Followed by, in between you can make some changes, or like you can give, like for example at this point, if the coolant is required, M08, obviously coolant will be required. Once you uh, turn on the coolant, that need to be turned off at this point. Maybe at this point you need to turn off the coolant also, M09, that is required. Spindle can also be stopped at this point. It is M05 to stop the spindle, that is also required. Alright, other than this, you can give a tool number here, T followed by some numerical, maybe 01, that is required. Alright, that can be written. Okay, so it is all you who are going to decide whether you are following absolute system or incremental system. And other than this, again, given based on the given question, inch or metric information. If it is inch, G71, sorry, metric, G71. If it is inch, G72 is the command. Likewise, you can also specify, as the depth of cut is Z, you can also specify that we are working on G17, where this represents expert line. Alright, this is a simple program for a given profile. The profile may contain some different shape and size. For example, this might be the profile shape. Okay, everything you have to decide accordingly. You have to plan. There might be fillet at this point, there might be fillet in a different direction. Everything you have to plan. Okay, so this is how a simple skeleton model of CNC program can be written. With some minor changes, this can be sent for production. All right, this is all for this session, and if you find or if you have any queries, you can post it in the box given below. Thank you.